Google just released TabFM, which is the most powerful foundation model that they have ever built for tabular data. Powerful enough to beat machine learning models that a data scientist would spend weeks tuning. Think about problems like churn, fraud, credit risk. This can do just one pass without any training, without using a single row of your data. Now, I've spent 22 years in enterprise tech, and most of that time I've built traditional machine learning systems, and now I'm building agentic AI. And the very first rule I have ever learned in ML was this: classification and regression belong to models you train yourself on your data. I believed that for 2 decades. Now, Tab FM has actually broken my conviction. So let me tell you what that machine learning rule will actually cost you, right? So you'll clean the data, you will engineer the variables or the features, and then you will pick the right model from multiple models, and then you will fine tune it, and then you will refit it, right? Think of this as 3 weeks of a data scientist's life before a single business person sees one prediction. If you think about TabFM, it skips all of this. It'll just do one forward pass because it has frozen weights, it has no training requirement, it has no GPU spin-up required. Zero shot TabFM actually beats gradient boosted trees that were actually heavily tuned. Not default XGBoost, but tuned XGBoost. Now, TabFM doesn't show you any of this from the outside. You basically hand it a table and you get the predictions back, right? That's it. So what I did was I built a UI to explain this so that it opens the box and helps you understand how this works. So a quick note before we get there: all opinions are my own and do not belong to my employer. All right. With that, let's get into it. All right. So what you're seeing on the screen is a UI that I built in order to explain Tab FM so that we can really understand what's also happening under the hood and how does it fit with different industries, right? So what we're going to do here is we're going to start with a personal risk. It could be an insurance, it could be credit card default, it could be anything of that sort, right? So that's the use case. And here is the data set from a context perspective, right? So you can give 5, 10, 15 rows of data, just as if you were giving that information to a large language model. So in this case, you have age, job, income, etc., and the existing risk label, right? So think of this as examples that you're giving. And then here, step 2 is the actual unlabeled records. That is where you're expecting the answers. Now, once I click on this, what it is really doing is it is calling the Tab FM model, and the model is now doing an in-context scoring and understanding. And then based on that, it is able to provide the score here, right? So this person has a low risk, this person again has a low risk, and this person has a high risk, right? So you already saw the answer over here. So under the hood, this is obviously using the transformer methodology, because remember, this is a foundation model which Google has built. So there are basically 3 stages that you will see. Stage 1 is the column attention, stage 2 is the row compression, and then stage 3 is the ICL transformer. Now, when you look at column attention, this is where attention actually runs down a column. So every age value attends to every other age value, right? And that's how the model works out what $80,000 means in the specific table, right? Like by looking at the whole column, not just one cell. So that is what it is doing as the column attention. Now, the second part is the row compression. So now attention flips and runs across the rows, and it collapses that entire row into one vector, right? One number list that represents the whole customer. And that's why it stays fast. So attention runs over rows and not every individual cell, right? And the third piece that you're seeing is the ICL transformer. It basically takes those compressed rows and treats your labeled ones as context and your unlabeled ones as the question. So that is what is called ICL, which is in context learning. The same mechanism as an LLM reading a prompt, except the prompt is basically your spreadsheet, right? Now you can see here is the two-way attention card down the column, which is all this, right? And then across the rows alternating. So it basically starts with something like this and then goes alternating. So standard transformers only read in one direction. Tables are 2 dimensions. So this one reads both ways, right? So this is the actual cross attention matrix between your question and your examples. Again, rows are the unlabeled people. So you can see row 1, row 3, row 4, row 5. And columns are the labeled example, right? So every cell becomes an attention weight, how strongly this question attended to that particular example. And this one is the softmax function, because that's the embedding dimension, right? So the 30-year-old engineer attended 94% to the 25-year-old engineer. That's where low res came from, right? So that isn't a black box. The attention weights are the explanation. So the weights obviously are frozen. That's why you will see the response in milliseconds. So this 18.4 milliseconds is my sandbox response time, not Google's benchmark. So just wanted to make sure you're aware of that. And then you can look at like other industries as well, right? So in this one, you look at a B2B kind of SaaS, right? So you can kind of run this and it'll give you the similar example. Again, healthcare, depending on the use case here, you can run this as well. And then fintech again, right? Like disputes and stuff like that. So the idea is this is a large language model which can work across any industry and any tabular data. And that's what I really wanted to explain, right? So you can now see how this actually works under the hood. And obviously, when you give more context, the improvement under the RSC curve becomes much more better. You can see this kind of simulation, and you can also see same accuracy here compared to the work that a data scientist would need to do versus over here, right? So that is the idea, and this is how you're able to save a lot of cost. So that was TabFM in detail for you. I hope this made sense. One more thing, and even if you have never written a line of code, please stay with me because this tells you something. If someone on your team wants to use TabFM today, this is it. The whole thing, 6 lines, 2 imports, load the model, hand it to your table, and then predict. Which brings me to what I want to leave you with. This is definitely not the end of machine learning. Maybe it is the end of one specific area, the tuning, the feature engineering, the week you used to spend just getting to a baseline. That's what those 6 lines replace. Everything after the baseline is still the hard part. Is your data any good? What does a wrong prediction actually cost you? When is the model confidently wrong? No foundation model answers those for you. So the way to think about this could be the floor just came up, the ceiling did not move. All right. So that was what I wanted to talk to you today. I hope you found this insightful. Please let me know in the comment section if you have any questions. And if you're new here, please hit that like and subscribe button so that I'm aware that this is resonating with all of you. Thank you very much for your time. Thank you for watching, and I will see you in the next one.